Here we have a graph drawn on the grid, and you're asked to write the equation of the line. Well, the general equation of the line of a straight line is y equals mx plus c. C is the y-intercept and m is the gradient. So what we need to do then is to find c and m from the graph. So here the y-intercept would be 4, so we have found the value of c, so c equals 4. So let us find m. M is the change in y divided by the change in x. So what we can do from this graph is to make a right angle triangle, and then we can find that value. So we could make a right angle triangle here, and the gradient then would be the change in y divided by the change in x. The change in y here is 1, 2, 3, 4 units divided by 1 unit, which is the change in x. So this is 4 and that's 1. The graph is sloping upwards, so the gradient is positive as well. So we have 4 for the gradient. So we can write the equation then as y is equal to m, which is 4, and then c is 4. So the equation of the line is y equals 4x plus 4. So here the gradient is 4 and the y-intercept is 4. Let's examine another question. So we know that the equation of a straight line is y equals mx plus c. So let's write that. So we have y equals mx plus c. Again, c is the y-intercept, so we need to look on the y-axis and see what value that is. That's minus 6. So we have c as minus 6. That's our first value there, minus 6. So we need to find m now. The line is sloping downwards, so we can make a right angle triangle and identify the value of m. So here, if I make a right angle triangle from here, going downwards to here, we can see that the change in y here would be 1, 2, 3, 4 units. So that's minus 4 because it's going downwards. And the change in x here would be 2 units. So the gradient is the change in y over the change in x. The change in y here is minus 4 and the change in x is 2. So the gradient is minus 2. So we can write our equation then as y equals to minus 2x minus 6. Let's examine another question. So here we have another line on the graph. So we know that the general form for the equation is y equals mx plus c. So let's examine on the y-axis for that value. So here c then would be 1. C is the y-intercept, so we can write down our first value there. C equals 1. So we need to find m. Now we can make a right angle triangle on the line here. So let's do that. If you notice, the line is sloping upwards, therefore the gradient is positive. So this is our right angle triangle here. So it's a change in y over the change in x. So let's see how many units is that. So we have 1, 2, 3, 4, 5, 6. So that's 6 units. And the change in x there is just, let's see, 1, 2 units. So the gradient then is 6 over 2, which is the change in y over x. And that's going to give us 3. So we can write the equation then. Y is equal to m, which is 3, and then c is 1, so it's 3x plus 1. Let's examine another question. Here you are given a line drawn in a graph, and you're asked to write the equation of the line. Now the general equation of a straight line is y equals mx plus c. M here is the gradient of the line and c is the y-intercept. So let's examine the graph here. Here it cuts the y-axis at 5. So C here, the value C would be 5. So we can write down our first information here. C equals 5. So we need to get M now, which is the gradient. Now if you notice, the line is sloping downward, therefore the gradient is going to be negative. So all we need to do on this graph is to make a right angle triangle, and then we can determine the change in y over the change in x. So if we make a right angle triangle, let's say we make a triangle from here and then downwards. Okay, so here the change in y would be 1, 2, 3, 4, 5, 6. It's going downward, so that would be minus 6. And the change in x here would be 1, 2 units. So M here would be the change in y over the change in x. The change in y here is minus 6, and the change in x is 2. So the gradient would be minus 3. So we can write our equation then as y equals to m, which is minus 3, and then we have x, and c is 5. So what we have then, y is equal to minus 3x plus 5. Let's examine another question.